I've done right. Hang on. Oh. And no. We may do a good analysis on this one. Three steps here that I need to follow, I don't know. It looks crazy. Who knows, I may have a couple down here crazy. Guys, let's look at it here. I can assume that already. Look at the board here. It's supposed to be true for all positive integers. If I let k be 1, what happens here? Well, on the left-hand side, if I replace k by 1, what do I end up with? Well, see, right here, it's what, 1/4?
Yes, 1/4 times negative.
And I put it, what here, it's 4 there, I guess? True, guys? Plus, what, 5 there, if I replace k by 1, well, I'm gonna start with 1, is that true? That would be, these cancel, it looks like I get a 6. I did it quickly. Will I get a 6 over here? If I replace k by 1. Validates the two sides. Guys, if I try k by 1 there, I don't know, maybe not. Does this become 5 squared, subtract 1, if I replace k by 1 over there? And I think that's 1/4, I think it's 25 subtract 1, what's that, 24?
Yes.
Cancel, do I get 6?
Yes.
That crazy statement is true at 1. I need to write it out nicely for you yet, but is it true at 1? If I replace k by 1? It is. Arena, I'm supposed to now replace k by 2. Here, 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 and hope the two sides are the same. And then k by 3. And then the same routine. By the time Mr. Park gets his, he's going to be number 19.
Can we change the
You know, well, exactly, we could. And then it continues like this, so that I need those 3 steps in what they call induction to show it's always true. Now, if it helps you, since I've been using a K here, your textbook, I think, maybe used a K here. I'm putting an N here. It makes it a little bit easier to work with the N. Same process, though. PK, I'm just wondering with the class, I know this class can deal with it, but I'm just wondering. Okay, here goes. Step 1, you're supposed to show, and I gotta write the statement out, guys. Show statement is true at the very beginning. In fact, I think we did that earlier. We put an N in there, put 1/4. 5 raised to the first, subtract 1, plus 5 raised to the first. And of course, we've got to show all this. 1 plus 1, subtract 1. And we got this to be a 1 here. 1/4, that's 4. Not do it too fast. And over here, 1/4 of, that came out to be 25. Subtract 1. So guys, cancel here, we got a 6 altogether, we discussed that earlier. Over there, we get 1/4 of 24, which is 6 again. And therefore, the first statement of your induction proof is true. Now, what you're hoping for, if you saw something like this on the final, or you saw this after you leave me somewhere, you're hoping that your professor has given you a false statement. So step 1 will not work. In other words, you try as much as you can, and these will not match up, and Professor, you're trying to trick us here. This is a false statement, and you get to leave it. You don't have to do anything else. I gave you a false statement. Looks like step one's okay. Now, can someone tell me, well, we'll just look at this. What would step two look like? If we do this. Show statement is true. Now, assume statement is true up to a certain point, and we're going to identify that certain point as K.
You just write down saying that.
Write it down, write the statement down, but put a K in there.
Yes.
Okay, so it looks like this. 1/4, 5 raised to the K, subtract 1, plus 5 raised to the K. It's a mad problem here. 1/4, 5 raised to the K plus 1, minus 1. And you receive 4 credit there just to show, assume it's true, it ends equal to K. Wait.
I'm thinking just rewrite the left, part of the function.
Oh, right here?
Yes, like, spell it out and you rewrite it.
I will, sure. Good idea. When I get that step 3 on today. Guys, so far on these 2 steps, so if you did see one of these on the final exam, let's say maybe you do, then these 2 statements here are easily done. You'll receive credit for this for sure. Right? It's step 3 I'm worried about. Now step 3 says do this. Show statement is true at or for what n is equal to K plus 1. Okay, it's making sense, I think. Is that true, guys? This is the last one I'm doing today. Last one I'll be doing, period, on induction. Now what does it do? It says, please go back here. You've already shown this much. I know, rewrite it. And Wayne's going to tell me a way to simplify this here shortly. Rewrite it. Get this. Step 2 gets to be rewritten. Okay, I got that on the left. And now they're saying, please extend it. And I'll get the right hand side out of the way. Guys, I'm supposed to extend it to K plus 1. What would this what would this look like at K plus 1? Or can we even write it at K plus 1? That's what they're asking me to do now. Write at K plus 1, go 1 larger.
You just write the same one with replacing.
So you're going to replace this by K plus 1?
Yes.
And K plus 1? Wayne said, Professor, it might be nice if you simplified that first. Somehow played around with this, and then maybe have done it, right? With me, guys? Okay, now hang on. Just say simplify that first if you wish. Let me simplify first. This really simplified is by distributive property, that's 1/4, 5 raised to the K, subtract 1/4, plus 5 raised to the K. Oh, I know it's so tempting to call this 5/4, but you can't. So here, 1/4 times 5 raised to the K, tempting to call it 5/4, you can't do it. And 1/4 times 1, distributive property minus 1/4. Wayne, I do see this and this probably could be combined with like terms. I have 1/4 of that term there, and I got 1 down here. Could I put those together like terms? How many 5 raised to the K's do I have? 1/4 here and 1 here. Can I put them together? Or could I take out 5 raised to the K like a common factor? Okay, if I pull out 5 raised to the K, does that leave 1/4 and down here plus 1? Yes or no? If I pull out a 5 raised to the K in that term, a 5 raised to the K in that term, does it look like that? Woo, okay. 5 raised to the K, put those together fractions, was it 5/4, I guess? Yes or no? Is it 5/4? Now, does anyone see anything else I can do with that? From algebra? I brought in a tough problem here.
Five,
What
k
about
plus one.
negative 1/4?
Oh, I used the distributive property. I distributed the 1/4 on this. See that 1/4 times this? PK, good question. It's here. 1/4 times 1 is here. So that's gone. I used the distributive property. I distributed that 1/4.
When you take out 5/k?
Oh, I got you. So you, right here's a 1/4 here. And
what
then
about
you
the-
put 1/4 in. Got you. You're saying right here. N plus 1? In fact, oh, no. I see what you're looking at. I think at the 1/4 here in these two, that was what, 1/4 plus 1, I think you said? Do we still have this?
Yeah.
That's what I'm getting to. There we go. Jeez, look at this mess. And then got this on the side. PK, is that what you're saying?
Yeah.
Okay. Guys, can I do anything else with it? This is out of curiosity, I brought it as a challenge. Can you do anything else with it at this point? I took out 5 raised to the k here, 5 raised to the k here, I got this. PK says, Ramsey, make sure you remember that term was also there. Anything else I could do with it?
5k, times 5 equals 5k.
Look at this. Wayne, you add the exponents. Common base is 5. He says from algebra, you can add the exponents there. So make that 5 raised to, how much was it? K plus 1. And all that's over 4. PK minus 1/4. Yes or no? So far, so good? And then could I write all this over 4 as this? Wow. Yes or no?
Yes, and then to add,
Is that true? At
yes.
this point? Wow. Jeez. Let me see what's happening here, because we're not going much further here. We got this mess here. We did it by distributive property. And then we took out a 1/4. We did that business. Let's see, what else did I do? Was this term also still hanging on up here? Have I dealt with this term here?
Yes, we factored.
Did we factor that out from, these two? We took care of that. Is everything taken care of at this point? Woo! Wow. Now that's the left-hand side in, I guess, simplified version, right? And it's supposed to be equal to, what does this side look like at k plus 1? If I replace n by k plus 1, it even looks worse. It looks like this, 1/4. Guys, what is it, 5 raised to the, help me out, is that k plus 2? You go back and replace this n on that side by k plus 1? Yes or no?
Yes.
And then minus 1. Whoa! No one else is doing this in their class. I thought I'd bring this in to challenge you somehow. We're not gonna quite finish it up. You're supposed to try to show, Wayne, you're supposed to try to show if all this is done correctly, that this and this are equivalent. Oh, by the way, did I leave anything out here? Take that page out. Okay. You have to pick up from there and try to show the two sides are equal. Now, what you'd prefer, and I'd prefer, is that you would stick with one like on the handout. Or you remember the first one we did, which made much more sense, right? This one is going crazy on us. Now, can it be done? It can be done if you go back and organize and do everything perfectly. And then Wayne got me to where Ramsey would not be wise to simplify this left-hand side to begin with, right? We tried to simplify the left-hand side. Guys, I've done this before. We can make it work out. It would take a little time though. We can eventually make it this craziness work out for us. I just want to point it out to you. I doubt you ever see something like this. I thought I'd bring it in though, just to discuss it. Yes?
I'm confused how the left side is for K+1.
Hang on, where am I now? Oh, right here?
Yeah,
Down here? I think, hang on, let's see, where are we? Where was I took out a common factor of 5 raised to the K. Oh, right here, where was it? Guys, help me out here.
You circled it.
Oh, right here. That's understood to be an exponent of 1 on the 5.
yeah.
So from algebra, you are allowed to add these exponents.
I mean, I thought that we had to start with K+1.
Ah, beautiful. No, I was cleaning it up first. We were not to that point yet.
Okay.
He just asked me to clean it up first. And that's we'll go further. I see some of my students are interested in saying, Professor, please. No, I'm not gonna do it though. I know some of my students want to see it. Please show us those two sides are equal, Professor. I know it looks crazy right now. Wayne, I appreciate what you showed me here, but I did that just to make it look a little better. I had to jump back into it, clean things up, and finally show the two sides are the same. It will eventually work. Okay, I don't wanna go through all that. You don't wanna be responsible for something like this. But I just want to point out, sometimes these induction proofs are much more demanding than that handout or the one I did earlier. Okay, so let's just hold off on that. It's just, I thought I'd bring it in for discussion. Wayne, I like that though. You said just go ahead and clean that up. The common factor. Guys, it's almost time for a break. Now, here's what I gotta do. And, Mr. Park has a demonstration for us. In fact, I was thinking about showing this, just the period, save a little time. But, I think I've got students in here who are intrigued by something like this. Now, that's done. That's 11.4. 11.5, before we take a break, coming up, close down 11. Which I'll do definitely today. Let me point out one thing before we take a break. Let's go back to elementary school. Probably middle school. I don't think you do it down here. Please tell me. Does anyone recall seeing something like that? Step back and look at it. Somewhere in your math. I know you did, you may have been not focused that day in class. While the teacher was discussing it. Have we seen something like that before? Gia, do you remember what name, and here comes another mathematician, what name was given to this? It looks like a triangle. It's the shape of a triangle. Does anyone remember what it was called back then? Because that's going to get me started on the ending of chapter 11. Anyone remember a name given to it? Uh-oh. Pascal's triangle. Oh, another mathematician. Before we take a break, we're not going to do anything else with it. I'm doing something with it after the break to figure what it means. And I know you've seen that triangle somewhere. There's a pattern in that triangle. I can write more pieces to it. Something going on in that triangle. Mr. Pascal. Can you imagine these mathematicians coming up with this? And that was their life. That was it. Most of a lot of them were big in poverty. They didn't care. They was doing good math. Moved on. I know. Okay, guys, so I will pick up that and go from there. Now, if you're interested, Wayne and some of my other students, I think, might be interested in a full proof of that last statement. We could play around with it and get that to work out for us maybe later on. Guys, this is a good stopping place. I'll pick up this, finish up chapter 11, and then guess what? We're going to just briefly look at chapter 9. Your course is pretty much done. Guys, any concerns before you leave though? Okay, that last one was a mess. Okay, take a break, 15 minutes.